All right. So we're gonna go over some basics of fractions. Okay. I want to talk basically about what fractions mean, how to do equivalent fractions, and what they mean as a decimal. All right. Let's look at a couple examples. Fractions always look like this, where there's a number on top and a number on the bottom of a line in the middle. That line, which you probably remember, means divide. Okay. Which, as you probably remember as well, dividing means to cut into pieces, to split it up. So if we had something like, I don't know, 10 divided by 2, that would mean you have 10 things, and you cut it into two groups. We're going to do the same thing with fractions, but what's going to happen is instead we're taking like one entire thing, like a circle, okay, one entire circle, and then we're going to do something with the fraction. The idea is this bottom number is called a denominator. The top number is called a numerator. And I've written here what they mean. The denominator means how big the slices are when you cut up the circle. So for the first one we have over here, the 3/4, divided by 4, the denominator's 4, means that we would cut this into 4 pieces. The top number, the numerator, means how many slices we actually are using. Okay, so in this case, we have 3 out of 4, so that would be 1, 2, 3 slices colored in. So we have 3/4 of the entire pie filled in. If we had something like 2/3, like this second example, we would have to cut it into 3 equal pieces, which would probably make it a little more equal looking than that, okay? And then, but we're only going to be having 2 of them colored in that we're actually going to use. This third one, 1/2, means we have to cut it in half, but again, we're only going to be dealing with one part of it, right here, 1/2, okay? The thing I want you to understand with all fractions is that they're a piece, they're a part. That's what fraction means. So normally we've been dealing with whole numbers like 3, 5, whatever, okay? That means you have like 3 of something. Now we're going to be dealing with fractions, like 1/3, which means you have less than an entire. You have a small piece out of an entire whole number, okay? That's what fractions are. The other way that you can think about it is, like I said, this is division. So if you just take the number, for example, 3 out of 4, if you say 3 divided by 4, it'll actually give you a decimal, like 0.75. The middle one, 2 out of 3, will actually give you 0.666, and the third one, the green one, 1 out of 2, will give you 0.5. This is another way of looking at the numbers, and it helps us. It's easier to see this way. The idea is that when you look at 0.5, you know it's smaller than 1. The other reason this is helpful is that it's really easy to compare decimals because you can see right away which one's bigger and how much bigger it is. Whereas when it's written as fractions like these, you can maybe tell which one's bigger, but it's hard to tell how much bigger. So decimals can be helpful in that sense. But most of this unit, we're going to be working just with the fractions, not with decimals, because it's more accurate. The other thing I want to show you is equivalent fractions. So the idea is, if you have something like 3/4, you know what, let's start with 1/2. So I have an entire circle, 1/2 means that I have just this part colored in. The idea is that we could actually change it. We could make it so that the pieces are smaller. So for example, I could do that. This would now be a different fraction. If I looked at this fraction, it would actually be out of 4, because there's 4 pieces, and 2 of them are colored in. And the idea is 1/2 and 2/4 are actually the same amount. You can see that they have the same amount of the circle colored in. So it's actually possible, and there's an infinite number of possibilities, that you can continue cutting the pieces smaller and smaller. For example, here now we have 8 in total and it's 4 colored in. All of these fractions are actually the same amount, and you can switch between them. I did them by drawing, but I want to show you an easier way you can do it. So if you had to find a different fraction, and this is called equivalent, okay? Basically means that they're the same, they're equal to each other. That's why it starts with equa, okay? A way that you can do it is you can actually multiply it. So the idea is we're going to take our 1/2, and then we're just going to multiply it by 2. So I'm going to have to change both the top and the bottom number. So remember, I started with 1/2, and then I'm going to double. I'm going to double the number of pieces in total, times 2. So instead of being out of 2, it's now out of 4, because there's 4 slices. But when I did that, I also doubled the number of pieces that were colored yellow. That became 2, and that gave me the new fraction. Let's try it with another one. 2/3, if I wanted to change it and I did times 2, it would actually become 4/6. And again, these two are equivalent. They're the exact same. And if I drew it, 2/3 looks like this. Okay. 4/6 means that I'm making it look like this. And again, 4 colored in out of 6 in total. We can actually multiply by any number. So like if we took this one, 3/4, let's multiply by, I don't know, let's say like 5. Okay. So it would become 15 out of 20 because we multiplied the top and the bottom by 5. And now we got a new fraction. This new fraction is equivalent to 3/4. This is going to be really important when we do addition next. The last thing we need to know how to do is reduce. So the idea is that in fractions, there's actually like a simplified version of stuff. So for example, if I wrote this sentence, you can read it, you know what it means, but you know there's mistakes in it. The idea is the same with fractions. If you wrote this as your final answer, I know what it means, but it's not the best way to write it. It's not the agreed upon way to write it. It's kind of like bad math grammar. So what we have to do is reduce it. Reducing means that we try to make the fraction as small as possible. So just like when we were doing equivalent fractions where we multiplied and made it bigger, we're actually going to reduce by dividing and making it smaller. So what we have to do is we have to see what numbers we can divide by. The numbers I usually check are 2, 3, 5, and the number, whichever number is included in it. So in this case, let's try to divide by 2. If I do 4 divided by 2 on my calculator, it works. It doesn't give me a decimal. And if I do 8 divided by 2, it works too. It doesn't give me a decimal. So let's do that. When I change this fraction and I divide both numbers by 2, it becomes 2/4. Now, be very careful. After you've reduced it, you might want to check again to see if you can reduce again. And in this case, you can. We can divide by 2 again, and it actually gives us 1/2. And that is the simplified version. Again, 4/8 is equivalent to 1/2, but this is the reduced. This is the reduced and final answer. If you forget to reduce in a question, you usually lose half a mark, just a little bit. It's not a big deal, but it is important if you're aiming to get perfect and show your work properly. That's basically it for the basics of fractions.